A sudden shift in the behavior of 3I Atlas has left scientists grappling with a startling question. Could this interstellar object, once assumed to be a simple comet, actually be steering itself through space? The latest observations reveal something far more perplexing. 3I Atlas might have fired a jet in the wrong direction. This is no minor anomaly. The jet, which should have been aligned with the sun's radiation, is instead pointed away, defying all expectations of natural comet behavior. As we explore the bizarre jet and other unexplained phenomena, one question looms. What if 3I Atlas is not just another comet, but a deliberate, intelligent artifact from beyond our solar system? To understand the true significance of these unusual behaviors, it is essential to first delve into the detailed spectroscopic data collected after the object passed its closest point to the Sun. Following its perihelion in mid-November 2025, 3I Atlas was closely monitored using the Keck Cosmic Web Imager located at Mauna Kea, where high-resolution spectra provided a clear window into the chemical makeup of the comet's coma and jets. The data collected at approximately 1.51 AU from the Sun and 2.09 AU from Earth revealed some unexpected and puzzling patterns. The first striking observation came from the object's elemental composition. While most comets display a composition dominated by volatile ices such as water, 3I Atlas presented a decidedly different picture. The spectral analysis showed an unusually high concentration of nickel, far above the levels seen in typical solar system comets, indicating an anomalous presence of this metal. The nickel-to-iron ratio in particular stood out as being distinctly high, raising questions about the origins of the object. In fact, this ratio was much higher than that of even 2I Borisov, the first confirmed interstellar comet, which also showed unusual features, but did not exhibit this same level of metal enrichment. The high nickel content could imply that 3I Atlas is not composed of the usual ice and dust mixture, but may instead have a structure and composition vastly different from any comet we've studied before. Further examination revealed that the object's activity, particularly the behavior of its jets, was just as perplexing. Comets are known for releasing gas and dust as they are heated by the sun, but the alignment of these jets is generally predictable. The radiation pressure from the sun pushes the ejected material away, and so comets typically have tails and jets that extend directly away from the sun. But 3I Atlas doesn't adhere to this pattern. The jet it emitted after perihelion was not aligned in the expected anti-solar direction. Instead, it was misaligned, defying the normal rules of cometary outgassing. This shift in the direction of the jet is not simply a minor discrepancy. It suggests that there could be an underlying mechanism at work actively influencing the orientation of the object's jets. This raises an important question. Could the object itself be controlling its own direction, rather than simply being acted upon by external forces? If so, what could be causing this behavior? Could 3I Atlas possess some form of internal propulsion or maneuvering capability, possibly pointing to something far more complex than a natural object? As more data was collected, it became clear that 3I Atlas's unusual behavior wasn't limited to just its composition and jet orientation. The object's trajectory was also highly atypical. Interstellar objects like 2I Borisov typically pass through the solar system in highly eccentric orbits, often with no discernible pattern or alignment with the plane of the solar system. 3I Atlas, on the other hand, showed an unexpected alignment with the solar plane, deviating very little from the ecliptic, a plane that most of the planets in our solar system follow. While it's not completely rare for interstellar objects to pass near the ecliptic, the fact that 3I Atlas's trajectory seemed unusually precise raised the possibility that the object's path wasn't purely random. Perhaps its trajectory had been guided or controlled in some way, pointing to a deliberate course. Along with this precise alignment, the object's velocity was significantly higher than typical comets, adding another layer of mystery to its behavior. The speed at which 3I Atlas entered our solar system suggested that it wasn't simply drifting through space, but rather traveling with a purpose, perhaps following a planned trajectory. This, combined with its other anomalies, opened up the possibility that 3I Atlas was not just another interstellar object, but something intentionally directed, perhaps even engineered. As the peculiarities of 3I Atlas continued to unfold, Avi Loeb, a leading figure in the study of interstellar objects, began to explore the possibility that this object might not be a simple, natural phenomenon after all. With each new observation, it became clear that 3I Atlas exhibited behaviors that defied the typical patterns we associate with comets. The first major clue came from the object's composition. Unlike most comets, which are predominantly made up of ice and dust, 3I Atlas displayed a significantly higher concentration of nickel, a metal not typically found in such quantities in natural cometary bodies. This finding alone raised red flags. In Loeb's view, the presence of such an unusual amount of metal suggested that 3I Atlas might not be a mere cosmic wanderer, but something far more intentional, perhaps a technological artifact rather than a random celestial object. Loeb's exploration of 3I Atlas's anomalous trajectory further fueled his hypothesis. Most interstellar objects that pass through our solar system follow erratic, unpredictable paths. However, 3I Atlas's trajectory was unlike anything seen before. It moved with a precision that seemed almost deliberate, as though it were following a specific course rather than drifting aimlessly through space. Loeb noted that the alignment of its trajectory with the solar plane, the ecliptic, was highly unusual for an object originating from another star system. This alignment, along with the object's high velocity, made Loeb question whether 3I Atlas was simply a passive comet, or if it was instead under some form of control. Was it possible that this object was deliberately navigating through space, following a planned path? Could it be a probe sent across the stars by an advanced civilization? This hypothesis, though speculative, offered a fascinating alternative to the traditional explanation that 3I Atlas was just another wayward comet. One of the most striking anomalies Loeb pointed to was the behavior of 3I Atlas's jets. Comets are well known for releasing gas and dust in jets, a process driven by the sun's radiation. Typically, these jets align with the sun as solar radiation pushes material away from the comet's surface. However, 3I Atlas's jet didn't follow this pattern. Instead of pointing away from the sun, it was misaligned, directing its material in the opposite direction. This was a remarkable deviation from the expected behavior of a natural comet. If the object were simply a comet, its jets should have aligned with the sun's radiation, but instead it seemed to be actively controlling the direction in which it released material. Loeb suggested that this misalignment was a clear indication that the object was not subject to the typical forces that govern the behavior of natural comets. Could this misaligned jet be evidence of some internal propulsion system? Or was it perhaps a sign that 3I Atlas was more than just a cosmic object, but rather an intelligently designed entity capable of steering itself through space? The unusual polarization observed in 3I Atlas further strengthened Loeb's theory that this object might be more than just a comet. Polarization refers to the orientation of light waves reflected off an object, and it can reveal a great deal about the object's surface composition and structure. Most comets show relatively low polarization, which suggests that their surfaces are composed of relatively uniform, icy materials. However, 3I Atlas displayed an unusually high degree of polarization, a characteristic that is typically associated with materials that have more complex or ordered structures. In Loeb's view, this was another anomaly that pointed to the possibility that 3I Atlas was not a simple icy body, but something with a highly structured surface, perhaps even something deliberately engineered. The high degree of polarization suggested that the object's surface might be made of materials that reflect light in a unique way, a trait that is often found in artificial objects rather than natural ones. Could 3I Atlas's surface be the product of intelligent design rather than the random aggregation of ice and rock that we typically expect from comets? In addition to the unusual polarization, Loeb noted that the high velocity of 3I Atlas was another critical piece of evidence. Unlike most comets or interstellar objects, 3I Atlas was traveling at an extraordinary speed. Its rapid movement suggested that it was not merely drifting through the solar system by chance, but was instead following a deliberate, controlled path. The The high velocity, combined with the precise trajectory and unusual composition, made Loeb's hypothesis that 3I Atlas could be an intelligently designed object more compelling. This object, which initially seemed to be just another comet, began to appear more and more like a purposeful probe, a piece of advanced technology sent across the stars with an objective in mind. Loeb's hypothesis, while still speculative, presented a bold and intriguing possibility. The growing body of anomalies associated with 3I Atlas, its unusual composition, its high velocity, the misaligned jet, and the strange polarization, suggested that this object might not be a natural comet at all, but rather an artifact sent by an intelligent civilization. This idea challenges our traditional understanding of interstellar objects, which until now have been assumed to be random cosmic bodies. Instead, Loeb proposed that 3I Atlas could represent the first tangible evidence of extraterrestrial technology passing through our solar system. This hypothesis raises profound questions about the nature of life beyond Earth, the potential for intelligent civilizations, and the possibility that we might be witnessing a contact event with an advanced alien civilization. The evidence for Loeb's hypothesis is far from conclusive, but it cannot be easily dismissed. The anomalies observed in 3I Atlas are simply too striking to ignore. Whether this object is a technological artifact, a probe sent across the stars, or simply an exceptionally rare comet with unusual properties, the fact remains that it is not behaving like any comet we've ever seen. The precise trajectory, the high velocity, the misaligned jet, the unusual polarization, these features collectively paint a picture of an object that is not just a random visitor from another star system, but something far more extraordinary. Whether we are witnessing the first evidence of extraterrestrial technology or simply the discovery of a rare and unique natural object, 3I Atlas has already forced us to rethink everything we thought we knew about the objects that roam our galaxy. As we continue to study 3I Atlas, the questions surrounding its origin and nature only grow more complex. The possibility that it is a purposeful object, perhaps a probe or artifact sent across the stars, challenges everything we know about comets, interstellar objects, and the potential for extraterrestrial life. Whether this object is a natural phenomenon, an intelligent creation, or something in between, 3I Atlas remains an enigma. Its behavior continues to defy expectations, and the mystery surrounding its true nature will undoubtedly captivate scientists and the public alike for years to come. As we continue to observe this strange visitor, we may be on the brink of uncovering something far beyond our current understanding of the cosmos, something that could fundamentally change our view of life in the universe.